Welcome to this demonstration of the U2V methodology. I will be creating a Unity project and linking it to Vijeo Citect. This demonstration will use the M340 BMXNOR RTUconf Tool and the U2V Bldr tool to accomplish the linking. Imagine that we need to create a solution using DNPr protocol, including several different types of RTUs, and that there will be multiple RTUs of each type deployed. For the solution, I will use a Modicon M340, and this demonstration will focus on the RTU Type 1, for which I will create 3 instances. This demonstration begins with the assumption that the RTU Type 1 requirements have been created, tested, and validated completely. This includes the Unity Pro project, the M340 BMXNOR configured DNP3 point database, and the Vijeo Citect graphic user interface. Before beginning the demo, here's a quick overview of what is to come. The Modicon M340 is a very capable RTU platform with a wide range of communication options. For the demo scenario, the BMXNOR module is used for the DNP3 protocol. The BMXNOR has both server and client channels, and there can be multiple NORs in the rack. The defined DNP3 points in the Unity Pro project have included the U2V syntax for Vijeo Citect variables, alarms, and trends. The assumed validated Type 1 RTU has 153 DNP3 points, 63 alarms, and 12 trended analog values. After the 3 RTU Type 1 instances are created, there will be 1,227 Vijeo Citect variables, 189 alarms, and 36 trends, which all will be automatically generated by the tools. On with the demo. Here is shown that there is only a Unity Pro project in my target folder for this solution. I will first export the Unity project to a ZEF format. Here you can see the exported file has been added to the target folder. I will launch the M340 BMXNOR RTUconf tool and begin a new RTUconf project using the tool wizard. I will select the exported Unity Pro project and set some of the basic parameters required for the DNP3 communications. I will adjust the report by exception buffers and then move on to creating the server channels for the BMXNOR module. The RTUconf tool uses the Unity Pro XEF project export format for the duplication features, and the tool can create this file from the ZEF exported file. The tool's point editor shows the DNP3 points extracted from the Unity project, and here shown as tested and validated for the Type 1 RTU requirements. I will save the RTUconf project file, and here is the RTU project file in my target folder for this solution. Next, I will save the RTUconf.xml file for the BMXNOR module. It will be saved to the path and file name shown in the status bar of the tool. Here is the RTUconf.xml file in my target folder for this solution. Next, I will begin to create the 3 instances of the Type 1 RTU using the tool duplication features. I start by duplicating the RTUconf project file. The duplicator requires an output folder, which I will locate in my target folder for this solution. I will name the folder RTUconf PRJ files. The duplicator needs a list of the RTU sites to create, including the DNP3 and IP addresses for each. The tool includes a list editor with an import feature. I will name my RTUs First Street, Main Street, and Broad Street, as these could be possible real names describing the locations of my RTUs. With my list complete, I need to save the list, and this CSV list file will be used later by the U2V Bldr tool. I will save the list file to my target folder for the solution and give it the name RTUPrJ site list. Now I execute the duplication feature of the RTUconf project files, and in my target folder for the solution, you can see the duplicated files. The next step is to duplicate the RTUconf.xml file. I select the previously created RTUconf.xml file, and then I will set the required output folder to a new folder in my target folder for the solution, naming the folder RTUconf files. I can import the RTU project site list file, extracting only the information needed by the RTUconf duplicator, and then duplicate the XML files. Again, in my target folder for the solution, you will see the duplicated files. The last step to creating my 3 instances of the Type 1 RTU is to duplicate the Unity Pro project file. I select the exported Unity Pro project file and then set the required output folder to a new folder in my target folder for the solution, naming the folder Unity Files. Again, I can import the RTUPrJ site list file, extracting only the information needed by the Unity duplicator, and then duplicate the XCF files. Again, in my target folder for the solution, you will see the duplicated files. Finalizing this step is the automatic generation of the Unity Pro STU files. With the STU generation complete, here in my target folder for the solution, you can see the Unity STU files, ready to be loaded into my Modicon M340s. Now I will begin the next phase of deploying the 3 instances of the Type 1 RTU. I will only be demonstrating one of these systems, First Street, and I will get started by loading the Unity Pro project into my live M340. I will open the First Street project created by the RTUconf tool. I will connect to the M340 and download the application. Next, I connect to the BMXNOR module through its embedded web server and import the First Street RTUconf.xml file created by the RTUconf tool. Then I reset the BMXNOR module communications. And then start the M340 controller. Now it's time to create the Vijeo Citect application. I will create a new project based on the tab style and using the starter project. There are two first steps needed. First, to reference the U2V include project as an include project, and second, to create a user. Now I will move to using the U2V VJC Bldr tool. I will use the DNPr Server Builder utility to create the Vijeo Citect servers. I reference the RTU project site list file and the Vijeo Citect project. I enter a cluster name and the IP address of the server and generate the servers, and then update the Vijeo Citect project. Now I will use the batch processing feature of the U2V Builder to generate the variables, alarms, and trends into my Vijeo Citect project for my 3 Type 1 RTUs. I will add a new DNPr batch, then select the Vijeo Citect project for this batch, and then the folder where my RTUconf project files are stored for this batch. I will add all 3 of my RTUs from my Vijeo Citect project to the batch, and then auto-assign the RTUconf projects by name. The most commonly used DNP3 point types are added by default. I have also added quality for all of my input points. And now I process the batch. Here you can see RTU 171 complete, or First Street is complete. Next will be RTU 172, or Main Street, complete. And finally, RTU 173, or Broad Street, complete, and everything is done. I will update the Vijeo Citect databases and then use the U2V Builder utility, the Vijeo Citect Project Explorer, to show you the tags that have been generated into the application. The Project Explorer shows the record counts in the status bar. So we have 1,227 variable tags, 189 alarm tags, and 36 trend tags. And here you can see examples of the DNPr driver tags that were added automatically. Now I will build the Vijeo Citect graphics. I will begin by using the template that was used for the testing and validation of the RTU Type 1 sites. I will grab a copy of those graphic objects and then create a new graphics page in our Vijeo Citect project. I will paste the graphic objects into this page and then save this page as RTU-171. My testing and validation was all done with RTU5. So what I'm going to do is do a find and replace of all RTU5 and replace it with RTU-171 in this page. Accepting these replacements will automatically save and close the page. Next, I will reopen the page, save it as RTU-172, and then do the replacements with RTU-171 to RTU-172. I will repeat this process once again, opening RTU-171, and this time saving as RTU-173. With my page creation completed, I now need to create a way to navigate to those pages. The U2V Bldr has a navigation menu builder utility. I will use this to customize the tab style navigation menus. The utility has a tab style 1 navigation marker, which is used to identify tab style 1 navigation. I will create a tab for my RTUs. I will include some geographic segregation of my RTU sites. Like on the north side, we will have First Street and Main Street. And on the south side, we will have Broad Street. Then I will simply drag and drop my RTU pages to these navigation menu items. I will generate the menus and then update the Vijeo Citect project. The first step of the final testing phase is to pack and compile the Vijeo Citect project. And then I will run the computer setup wizard, as this was a brand new Vijeo Citect application. And then I will run the Vijeo Citect application and begin the testing. First thing to do is to log in to the application. You should see the customized tab style navigation menus, and you can see that I have communications with my RTU. Now I'm going to switch back over to my online Unity Pro project and force an alarm condition to exist within the Vijeo Citect system. I have operator screens from my testing and validation, and we'll throw a smoke alarm at it. My Unity Pro project was configured with alarm diag blocks, which feed data into the diagnostic buffer. So here you can see that the alarm diagnostic buffer includes the smoke alarm. Switching back over to Vijeo Citect, we can see that the smoke alarm has come in to the alarm banner, and going to the alarm page, we can see that the smoke alarm was coming from First Street. So now I will do a quick wrap-up. I started with a tested and validated RTU Type 1 UnityPro project that included in the custom column of the data editor the definitions of the Vijeo Citect variables, alarms, and trends with DMP 3-point definitions. I used the RTUconf tool to generate and duplicate the RTUconf.xml files and the UnityPro STU files. These were loaded into the M340. Then the U2V VJC Bldr tool was used to generate the Vijeo Citect variable, alarm, and trend databases. And I demonstrated a fully working system all in less than 20 minutes. Imagine if there were 30 RTUs or 300 RTUs. I hope that you can see the value in the U2V methodology and tools. Subscribe to this channel to see more demonstrations of UnityPro tools, tips, and tricks.